Python's timeit doesn't always scale linearly with number. I'm running Python February 7, 2010 on a 16 GB, 2.7 GHz 5, OS X 10.11.5 machine. I've observed this phenomenon many times in many different types of examples, so the example below, though a bit contrived, is representative. It's just what I happened to be working on earlier today when my curiosity finally piqued. You'll notice that, from 100 to 1000, there's a factor of 10 increase in the time, as expected. However, 1e3 to 1e4, it's more like a factor of 50, and then a factor of 2 from 1e4 to 1e5, so a total factor of 100 from 1e3 to 1e5, which is expected. I'd figured that there must be some sort of caching-based optimization going on either in the actual process being timed or in timeit itself, but I can't quite figure out empirically whether this is the case. The imports don't seem to matter, as can be observed this with the most basic example. Where from 1e4 to 1e6 there's a true factor of 1e2 time difference, but the intermediate steps are 30 and 3. I could do more ad hoc data collection, but I haven't got a hypothesis in mind at this point. Any notion as to why the nonlinear scale at certain intermediate numbers of runs?
This has to do with the smaller number of runs not being accurate enough to get the timing resolution you want. As you increase the number of runs, the ratio between the times approaches the ratio between the number of runs.
If you want to do timeit, please consider subscribing.